So let's review asymptotes and rational functions in this video. So the definition of rational function is that we have a ratio of two polynomial functions. So we have, let's say, f of x on top. Oh, I'm sorry, let me use a different letter. Let's say p of x on top. And let's say q of x is in the bottom of the fraction. So you have a ratio of two polynomial functions. But remember, just like a fraction, you cannot have 0 in the bottom of a fraction. So q of x is not a 0 polynomial. Q cannot be 0. So the domain of f consists of all x values, which the denominator function q of x is not equal to 0. Okay, so just review a rational function and what the definition is. But let's talk about asymptotes in this on this page. Okay, so first type of asymptote I want to talk about is the vertical asymptote. We're gonna say that a line x equals a is a vertical asymptote. Of f of x if any of these statements are true. So first, if the graph is approaching this a value, this number from the left or from the right, okay, the graph is trying to get to this number. I should probably draw a picture for you. Okay, look at this for me, okay? Let's say this is my graph, okay? And let's say a is right here. Here's my a, okay? I'm going to sketch a vertical asymptote and see what the graph does as it gets really close to it, okay? Let's say this orange line is that vertical asymptote of a function, okay? This is x equals a. As the graph, a function approaches, okay? I'll try to use some colors for you. If x approaches a from the left, okay? And it does this, okay? See, it's trying to go to this orange line, but it skyrockets up and approaches infinity. We say this is a vertical asymptote, okay? Or it can be going straight down too, but I'll do that on the other side, okay? If it's approaching a from the right and it's just going straight up, then we say this is a vertical asymptote, okay? So there's this line, okay? It's not going to be graphed, okay? But it's like an invisible force where the line, where the graph gets closer to it, it just goes straight up to positive infinity, like getting really, really close to it, okay? And they don't have to go up, they can also go down, you know? So I can just graph something very similar, and let's say this is my a right here, and I'll sketch a dotted line, okay? That's my vertical asymptote at x equals a, okay? This is x equals a. And let's say this time x is approaching a from the left, okay? It's getting close to a, but then as it gets really close, it skyrockets down. If it does that, then we say this is a vertical asymptote. It can do it from the right side too, right? This blue graph, it was on the right side of this dotted line, but as you get really close to this x equals a, it goes straight down. So if that happens, we also call that is a vertical asymptote, okay? If any of these statements are true, okay? It's not all gonna happen at the same time, okay? For typical rational functions, you may have a graph that looks like this, okay? Like let's say this is your a right here, okay? And you have a vertical asymptote at this value. What the graph will do is as it gets closer to this graph, the left end may skyrocket up, and the right piece of the graph is going down. So if you see that kind of behavior around that x-axis, I'm sorry, the line, the vertical line, that's what we call vertical asymptote. Okay, I'll talk about how you can find the vertical asymptote by looking at the equation, but that's how you can find where a vertical asymptote is happening from a graph, okay?